the rest of 7.8, so we did 7.8 when we did factoring by grouping, and now we're back to this idea of factoring completely, which means usually there will be more than one strategy that can be used. So on the Google Classroom, I posted an assignment called, or not an assignment, just a document called Factoring Strategies, and so if you want to reference that while you do these notes or while you do your IXLs or your assignments, that might be a good idea. So I always want to first, always check for a GCF. And then if I can keep factoring, I'm going to keep factoring. So when I look at number 1, when I recognize a greatest common factor, the largest number that I can factor out of everything is a 3. And then the x's that I can factor out, I can factor out an x. So if I have 3x to the third and I factor out a 3x, I'm left with x squared. When I take 6x squared and I factor out a 3x, I'm left with plus 2x. And when I have a minus 24x and I factor out a 3x, I'm left with minus 8. And so before I say that, okay, well, I did one strategy, that means I'm done, I have to make sure that I can't do multiple different strategies. And so when I look at what's inside the parentheses, it's got 3 terms. And it's got that x squared and then the x term and then the number. And so I want to see if I can use just basic factoring to factor this. The only way to separate x squared is x and x. So I'm looking for 2 numbers that multiply to be negative 8 and add up to be 2. So multiply to be negative 8, so it could be negative 1 and 8. It could be negative 2 and 4. It could be positive 2 and negative 4. Or positive 1 and negative 8 for that matter. But the only 2 numbers that multiply to be negative 8 and add up to be positive 2 are negative 2 and positive 4. So negative 2 and positive 4. And so I don't want to lose my 3x. So my final answer completely factored is 3x times x minus 2 times x plus 4. So that whole thing. So I'm not done until I've factored it completely. And if you multiplied all of those things out, they would all multiply together and get you back where you started. So number 2, what is the greatest common factor? Well, between 7 and 28, I can factor out a 7. And then between x to the 4th and x squared, I can factor out an x squared. So in the first term, I'm left with, if I take out 2 of the x's, I'm left with 2. So x squared. And then in the second term, 28 divided by 7 is 4, and the x's cancel. And so I want to recognize this as the difference of 2 squares. So x squared minus 4 factors, what do you square to get x squared? You square x, and what do you square to get 4? 2. So x squared minus 4 factors into x plus 2. And x minus 2. And I don't want to lose the 7x squared out front. So 7x squared, how did I do that? And then 7x squared times x plus 2 times x minus 2. So when they say factor completely, I have to keep going until I cannot factor any further. And then if you see a problem that has an equation in it, if there's no equation, your answer is just a list of factors. If there's an equation, then they want you to solve for x. They want you to find x equals blank. And so it probably or will need to require factoring because I will use what's called the zero product property, which says if anything is multiplied to equal 0, then one of the factors has to equal 0. But notice that I don't have a 10x product property. I need to get one of the sides set equal to 0, so I'm going to subtract 10x. So I've got 2x to the third plus 8x squared minus 10x equals 0. So I would look at that left side of the problem as one of these that I just did where I have to factor it completely. So I'm going to factor out a 2 and an x. And when I do that, I'm left with x squared plus 4x minus 5 equals 0. And then I look at what's inside the parentheses and I factor further. So I factor x squared into x and x, and the two numbers that multiply to be negative 5 and add up to be 4 would be a positive 5 and a negative 1. And then I don't want to lose my GCF out front, 2x. So 2x times x plus 5 times x minus 1 has to equal 0. So I actually have 3 different factors here. I've got 2x, I've got x plus 5, and I got x minus 1. And so I have to say, when does 2x equal 0? When does x plus 5 equal 0? And when does x minus 1 equal 0? And I'm going to have 3 solutions. So in the first one here, I'm going to divide by 2. 0 divided by 2 is 0. So x could equal 0. If I subtract 5, x could be negative 5. And if I add 1, x could be 1. So the 3 solutions are 0, negative 5, and 1 for number 3. If I plugged any of those in and I carefully checked my answer, I would get a true statement. So I have 3 answers. Number 4, I'm going to factor first. X cubed minus 25x. I can factor out an x, so I'm left with x squared minus 25 equals 0. So again, recognize that what's in the parentheses is the difference of 2 squares. So 25 is 5 squared. So this is x plus 5 and x minus 5. And I don't want to lose my GCF out front, x. So these 3 factors have to multiply to equal 0. So what makes x equal to 0? When x is 0. What makes x plus 5 equal 0? When x is negative 5. And what makes x minus 5 equal 0? When x is 5. So again, there are 3 solutions. So the fact that the original problem was x cubed is a good indicator that there's going to be 3 solutions. And then the last problem here, number 5, it's just a practice problem, so if you want to pause the video and give it a try, you can. I just wanted to make sure if everything's all over the place, just remember it's a 0 product property. Get one of the sides to equal 0. I like the fact that this c to the third, which is the biggest degree, is positive, so I'm going to choose to add 12c over, and it doesn't have a like term, and I'm going to add 3c squared over, and it does have a like term, so I can combine negative 10c squared plus 3c squared. So I've got in standard form c to the third minus 7c squared plus 12c equals 0. So I move everything over to one side. I factor out the GCF, which in this case is just a c, and I'm left with c squared minus 7c plus 12 equals 0. And then what's in the parentheses, I can factor into c and c. So the two numbers that multiply to be 12 and add up to be negative 7. So pause the video and come up with it if you want to beat me to it. But it's negative 4 and negative 3. So c minus 4, c minus 3 equals 0. So c equals 0, c minus 4 equals 0 when c equals 4, and c minus 3 equals 0 when c is 3. So there's